All right, this is our last lesson before spring break. And I hope it goes well, and I hope you really have been keeping up with your work, and I am missing you right now. All right, so we are going to do something called scientific notation. So this is a brand new topic. You might have been taught it in 7th grade, but I'm not sure. It should be a super easy topic, assuming you also have your calculators out, your Desmos calculators out. But it's really important to know. All right, so some vocabulary you should be writing down. A number is expressed in scientific notation when it is in this form. Okay, A times 10 to the n power, where A is a number between 1 and 10, and n is an integer. So, we need to determine which one of these are in scientific notation. So if I look at this one, this is a number, this first part, which is A, is a number between 1 and 10, okay? And n is an integer, which is just like a number. This one is not in scientific notation because 18 is definitely not between 1 and 10. This one also not between 1 and 10. This one is. This is in between 1 and 10. -5 is an integer. This is between 1 and 10. 8 is an integer. This is not between 1 and 10. Okay, so scientific notation, the numbers have to be between 1 and 10. It doesn't matter if there's decimals or whatnot, but they have to be between 1 and 10. So when using scientific notation, there are two types of exponents. Positive, which represent really, really big numbers, and negative, which represent really, really small numbers. If an exponent is positive, a number gets larger, so your decimal's moving to the right. If an exponent is negative, the number is getting smaller, so the exponent is moving to the, or the decimal is moving to the left. Okay, so make sure you are writing that down. This is going to be really important for later. All right. All right, so I'm going to be changing these in from scientific notation, which they are in right now, to something called standard form, which is just what the number actually is. So I'm going to take the first one, 6.832. And notice this is a positive exponent. So that means that my decimal is going to move to the right because my number is getting bigger. All right, and that tells me how many I'm going to move it. So I'm going to take my decimal and move 5. 1, 2, 3. I know I don't have any more numbers, but I'm going to keep with the like whoosh, the like swoop thing. So 1, 2, 3, 4, 5. My decimal goes here, and in the spaces provided, I put zeros. So my whole number, when it's big like that, is going to be 683,200. So 683,200 is my number. Now, I can put the decimal after it. I don't need to when it's a big number like that. On the converse, okay, when it is a negative exponent, I'm going to be moving to the left because I'm going to be making this a decimal and really, really, really small. So I'm going to go 1, 2, 3, 4, 5, 6, 7. My decimal goes here, and I'm going to add a bunch of zeros. 1, 2, 3, 4, 6 zeros. Okay, so my new number is 0.0000005248. It's a very, very small number. Okay, so that was me going from scientific notation to standard form. Now I'm going to go from standard form to scientific notation. So we use scientific notation because we don't like to write really, really big or really, really small numbers. They're just time consuming, and if you have to say it, it's really difficult. So one thing that we do to help that is write it in scientific notation. So I'm going to take this, and to get my number in scientific notation, I need to put my decimal so that I have a number between 1 and 10. Okay, so right now on this number right here, this number right here. My decimal is technically at the end. All right, so to change it so that I have a number between 1 and 10, I need my decimal to go between the 5 and the 4. So I need to count how many I needed to move it over. So I'm moving it 1, 2, 3, 4, 5. So I'm going to put 5.48. The zeros don't matter anymore. All right, times 10. And then I move my decimal 1, 2, 3, 4, 5. And this is a big number. So my decimal is going to be positive. Or sorry, my exponent's going to be positive, and it's going to be 5. 1, 2, 3, 4, 5. Okay, so this is my number in scientific notation. Okay, same thing here. My decimal is going to need to be between the 1 and the 3 because I want it to be between 1 and 10. So I need to move my decimal 1, 2, 3, 4. So my new number will be 1.358 times 10. And because this is a really small number and a decimal, I'm going to write to the negative 4 because I moved my decimal over 4. Okay, I know that these are not very many examples, but I'm trying to just provide you brief explanation as to what is going on. And you should be able to look back at these videos and rewatch to understand how to do it. Okay, so now we're going to multiply in scientific notation. This is so similar to when we multiply exponents, all right? Because tens are the same base here. We have the same base. So if you remember when we're multiplying with exponents, we keep the base, add the exponents. So in this case, it's very similar, except that we're going to first multiply the two numbers here together. So we're going to take 2.3 times 3.7, and we get 8.51. Okay, and then we're going to write times 10 to the exponents, and I'm going to add my exponents. So 2 plus 5 is 7. So my new number is 8.51 times 10 to the 7th. Now, this works like this because, and I can stop here because this number is between 1 and 10. If it wasn't, I'd have to change it, and that I will get to that. Okay, so we're going to do another one. We're going to multiply the 3.8 and the 6.4. 3.8 times 6.4. And I'm going to get 24.32. Okay, times 10. And then I'm adding the exponents. So 4 plus negative 2 is 2. All right, now I need to change this number because this is not between 1 and 10 and it needs to be. So in order for it to be between 1 and 10, I need to move my decimal to the left. And when I'm moving my decimal to the left, my number is getting bigger. Okay, so you might want to make a note of this. Decimal, if I'm going to the left, exponent is bigger. Okay, and I'm only moving 1 to the left, so this becomes 2.432 times 10 to the third power. Okay, so I went to the left, exponent's bigger. Similarly, if I was going to the right, my exponent would get smaller. Okay, so that's my answer to that one. All right, now we're going to divide, which again, same rules apply as exponent rules. So I'm going to start by dividing the numbers. So 6.3 divided by 2.1. That just gives me 3 times 10. And then I subtract my exponents when I'm dividing. So 10 minus 2 is 3. So 3 times 10 to the third. That is my number in scientific notation. Okay, so another one. So this time I would do 1.7 divided by 3.4. And that gives me 0.5 times 10 to the negative 9, because negative 7 minus 2 is negative 9. Now, this is okay. This is the case. Scientific notation is the only time it's okay to leave my negatives in my exponents. Okay. So now I need to move this because this is not to the right power. All right. So I'm going to move this, and I'm going to say that this is 5, and I'm moving my decimal over 1, times 10. And if we just said moving to the left makes the number bigger, moving to the right makes the number smaller. So what's 1 less than negative 9 would be negative 10. All right. That is all I have for this. If you have any questions about the lesson, please let me know, and I will answer them as soon as I possibly can. And if I don't talk to you, have a great spring break. And be safe.